अब सही है। देख लो अच्छे से। Online students, any doubt till now?
So we can say that this initial value is of the impulse.
No, this is not the initial value of the impulse. This is the slope, na? It is the value of the slope. It is the value of a slope.
The estimated value of this is actually impulse input.
You can interpret it like this also. But right now, this is the different thing. Don't mix. Right now, don't mix, because we are saying that at t tending to 0. Okay, yeah. In the impulse, let's take in the impulse. Then in the impulse case, you are getting what? Kp by tau p. Only Kp by tau p, na? That's a different thing. मतलब भी पता होना चाहिए इसका, ये क्या चल रहा है, लिखना नहीं है बस खाली। अगर नहीं पता चल रहा तो पूछ लो दोबारा से। Meaning of this is in S domain using initial value theorem. S domain का इसमें मतलब होता है कि हम इनिशियल वैल्यू थ्योरम का यूज करें। एस डोमेन में मतलब ये है, अगर t इज इक्वल टू 0 पुट कर रहे तो हम
टी डोमेन को एस डोमेन में चेंज करेंगे तो इनिशियल में यूज कर लेंगे।
नहीं, ऐसा नहीं है।
जब वो 0 होगा तो ही
हाँ, वो कह सकते हो। इनिशियल वैल्यू थ्योरम का मतलब ये है कि t टेंडिंग टू 0 कर रहे हैं d डोमेन में और s टेंडिंग टू इनफाइनाइट कर रहे हैं s डोमेन में। इसका मतलब so if you have given only ys thing, don't convert into yt to calculate the initial value or slope at t is equals to 0. Apply this thing. Okay, it will save your time. Online students, any doubt till now? Okay, you missed the first part. Okay, which first part? Just tell me. इससे पहले वाला। हाँ सर बताइए।
एस डोमेन में टी टेंड्स टू इनफिनिट, अगर इसको हम
एक सेकंड एस डोमेन में
टी टेंड्स टू इनफिनिट।
हाँ सही है। इसका मतलब ये है कि वी आर कैलकुलेटिंग द इनिशियल स्लोप ऑफ अ कर्व। The actual meaning of this thing is that we are calculating the initial slope. Okay, basically I tried to explain what is the meaning of that previous lecture that we have discussed. We have discussed now, if I travel with the initial speed, okay, it will take T is equals to tau p time to reach the ultimate value of response. Okay, and we have solved this one with the help of different equations in T domain. So how can we calculate the same results with the help of using S domain? So this is the way to calculate the value of T is equals to tau p by using S domain. हमने T domain में solve किया था, अब हमने S domain में solve कर लिया. That's the thing. पता होना चाहिए आपको. Okay, how you are able to solve these things when you have given only ys. If something is given, if equation is given in the S domain, you can also easily solve this thing if you know the tricks and how to proper use of final value theorem and initial value theorem. Online students got the point? Okay. So please remember these things. They can ask you in a form of multiple choice of MSQ questions. Okay, they will give you a statement in this one. They can form in any way. Okay, I will give you a test. That test will contain these things. Don't worry. आसान टेस्ट नहीं दूंगा, डिफिकल्ट टेस्ट ही दूंगा. Done with this thing? Okay. Now we are going to discuss. See, we have discussed what is first order systems. ना आप पूछोगे सर, how can we feel what is first order system? So for that today we are going to discuss the interpretation of first order system in real world. कि real world में कैसा first order system दिखता है वो हम पढ़ेंगे and how to make the equations. Okay, by using mass balance and energy balance. How you can model the first order system that is happening in the real world by using mass balance and energy balance. तो देखते हैं अंसारी साहब कितना आता है आपको मास बैलेंस और एनर्जी बैलेंस, और नेताजी आपको भी देखते हैं कितना आता है. देखो नेताजी तो सो रहे हैं. सो गए क्या? फिर कहाँ खो गए? किस चिंता में हो हमें बताओ. किसी ने कुछ बोल दिया, किसी का मैसेज आ गया? आते ही नहीं सर, आने चाहिए इसका मतलब. अंदर ही अंदर तो लड्डू फूट रहे. हाँ सर आने चाहिए, क्यों नहीं आए? तो मेरे दोस्त कह सकते हैं तो, है ना. वो खुश हो रहे, मैं भी खुश रहना चाहता हूँ. ओके, द फर्स्ट फिजिकल सिस्टम इज योर रियल लाइफ सिस्टम इज टैंक सिस्टम. ओके, और यू कैन से लिक्विड लेवल सिस्टम और टैंक सिस्टम. वो देखते हैं क्या होता है and how can we model this system to the first order system. This is your flow rate, Q in and Q out, right? Now, let's take this height as H, right? So what is happening at the initial steady state? Okay, at initial steady state, what is happening? Q is coming in, okay? What will happen? जब पानी अंदर आएगा, the height will increase, right? And after height will increase, what will happen? Hydrostatic pressure will exert. Okay, due to this what? Flow rate is also there, outward flow rate is there, right? It is Q naught. The valve is also there, and this valve applies some resistance to the flow, right? Now after some time, what will happen? This QI changes to QI dash. Some disturbance occurs. Okay, so let's take this QI is first 5 metric cube per second. So at steady state, when this is 5 metric cube per second, this will be what? This is clear, na? Okay. 5 metric cube per second. Now, due to some disturbance in the backward, this flow rate changes from 5 to 10 metric cube per second. So, when it changes from 5 to 10, what will happen? The height will increase. Okay, from HS to H. Some height we don't know, random height. Okay, because height is a variable. Now, when height is increases, what will happen? Hydrostatic pressure will increase. Okay, so what will happen when hydrostatic pressure will increase? Yes, Q naught is also increase, and we don't know. We don't know, but yes, Q naught will also increase. So it will change to what? Q naught dash. Okay, so we want some relation that relate the change in the output with respect to the change in the input. We want some relation. Okay, so for that, in this system, what do we have? Mass is there, flow rate is there, na? Means mass is there. So we will going to apply mass balance. We'll apply mass balance. Okay, so what will happen? Mass flow rate in minus mass flow rate out is equals to what? Accumulation, right? In minus out is equals to accumulation. In a simple way, in a very simple way. This is a mass balance, simple to simple. Everything is clear. सबको पता है कि कितना मास इकट्ठा हो रहा है, कितना पानी इकट्ठा हो रहा है टैंक में. हाँ, पहले बेसिक्स से स्टार्ट करते हैं. डोंट गो विद द मोमेंटम, राइट? आई कैन गो विद द मोमेंटम, बट अभी नहीं. बताऊंगा कि क्यों यूज नहीं कर रहे और क्या कर सकते हैं कि नहीं कर सकते. वी विल गोइंग टू डिस्कस दिस थिंग आल्सो. Mass in minus mass out is equals to accumulation. Okay, because something is going in and something is coming out. And what is going in and out? Mass. So simple to simple, we can say mass balance is there, right? So what is the mass in here? Mass flow rate in, you can say most precisely. कोई नहीं देगा. आप पहले आप बताओ. हाँ, इन टर्म्स ऑफ क्यू. अब मान लीजिए ये नहीं है, अब बोलो 10. QI. Okay. Okay, let's take density is Q or rho. Rho is the density. Density कितना परसेंट लो है यहाँ पर? वाटर ही होगा बेसिकली ना, राइट? तो ठीक है, डेंसिटी ले लेते हैं इसकी. सिंपल डेंसिटी, वी डोंट नो डेंसिटी बट डेंसिटी ले रहे हैं. तो बताइए क्या होगा? ओके, आप कह रहे हो कि डेंसिटी रो एस की, देन रो क्यू. तो क्यों रोना फिर, है ना? हंसो फिर. सो क्यू आई इंटू रो. अंग्रेजों ने सारी चीज गलत बनाई है, बेकार चीज, डिप्रेशन वाली चीज है सारी की सारी. मजा ही नहीं आता, है ना? कुछ और बोलना चाहिए था. माइनस मास आउट इज व्हाट? रो क्यू नोट ना. ओके, so this is Q naught into rho. What is accumulation? अंसारी साहब बताएंगे. बताओ accumulation. है? If this is, let's suppose this is area A. बताइए. हाँ बताइए. ये तो मुझे पता, सबका पता है. तो what is numerator? Accumulation. Can I say d of dt into rho into volume? Yes or no? That is area into HS. Area into H. This is the thing, right? Because area into H is what? Volume. Okay. Density is what? mass upon में volume, volume got cancelled, mass flow rate. Right? So you will see here units, left hand side unit and right hand side units are same. Okay, that is what kg per second. Here it is also kg per second. Now this is the equation that you will get, or you can say what qi, because density will remain constant. We are assuming that density will remain constant. Assuming this is the assumption. First assumption is density is not changing, right? So we will say this thing. And also area is also same due to symmetry, right? Area is taken out, right? We can cancel out density on both the sides. This is the thing that I will get, right? This is the thing that I will get. Now, after that, how to proceed? अब proceed कैसे करेंगे? Because there is another thing, another variable is there in the system. It is R. Because R is also affecting Q naught. This is a valve, na? This is a valve. I can increase and decrease the resistance, na? R variable is also there, and we need to include R variable also in our system because it is also affecting the Q naught. But how it is affecting, we don't know. So we want a relation that relates Q naught and R, because Q naught is directly affected by the R, na, in some way, in some relating way. So we want a relation between Q naught and R. But we know in your fluid mechanics, we know a relation, small relation we know. What is that relation? We will see. The relation is that, you know, this tank system is there. If you put a hole here, okay, if h height is there, okay, what is the velocity? कोई नहीं बोलेगा, अंसारी साहब बताइए. ओके, मुझसे क्यों पूछते हो सर आप? क्योंकि अच्छा लगता है पूछना. आप बताओ चलो. फॉर्मूला पूछा है, यूनिट्स नहीं पूछी इसकी. ऑनलाइन स्टूडेंट्स, एनीवन, व्हाट इज द फॉर्मूला फॉर दिस वन? ये तो हाथ पे होना चाहिए. दिस इज एकेडमिक क्राइम. ये तो मैकेनिकल और सिविल और केमिकल में आता है, दोनों में. दिस इज द थिंग ना, दिस इज द थिंग ना, वेलोसिटी, राइट? नाउ एंड कैसे कैलकुलेट करी? और यू कैन से डायरेक्ट अप्लाइंग बर्नौली थ्योरम बोल सकते हैं, राइट? नाउ can I multiply V with A on both the sides? What you will get? Yes or no? This is what? Q. हाइला, ये तो आ गया. करता ना जादू में. हाइला, ये तो आ गया. रिलेशन आ गया. देखो वो आ गया. अब क्या कर सकते हैं? Q is equals to what? A, or you can say 2A square G into, this is the thing, or you can say Q K, some constant. This is constant, this is constant. I can take another constant. Yes or no? Or I can say what? Q, because see, this is the thing, this is the major thing. This is the height. This is the height. Height is a driving force for the flow rate. Okay, what is the another thing that affects the flow rate? Resistance. Resistance is another thing. This is the constant. And R is what? 1 by K. And R is your resistance. आप पढ़ चुके हो चीजें, बट मॉडिफिकेशन कर रहे हैं थोड़ा सा इसमें. यहां से कुछ नहीं किया. इस के कांस्टेंट को हमने मॉडिफाई कर दिया. मेरा मन कर गया. सी, आई एम building up a equation, a relation for Q naught and R, because this Q naught is affected by the R resistance. How it will affecting? We're going to discuss, right? Now, what is happening here? This is the thing. This is a constant, but this is not actually a constant. It's a resistance. That is the resistance means for this flow rate, this is the height, right? If the system is ideal, nothing is there, means resistance is not there. Okay, this will be not there, but the resistance is there, means this flow rate is not the actual flow rate, or you can say this flow rate is not the ideal flow rate. Some resistance is there in the wall, and the resistance is given by this thing, right? But there's a catch, and what's the catch? This is not for standard thing. This is for a special case. For this one, we want a standardization. Okay, we want a standard case. So what is the standard case for that one? Yes or no? This is a standard case in the real world, not the ideal world. Okay, let's suppose when resistance is constant, right? And what is the meaning of resistance is constant? What is the meaning of that thing? Nah, that is not the thing. If I am saying resistance is constant, what is the meaning of that thing? एरिया तो पहले भी कांस्टेंट था, जब तो के कांस्टेंट लिखा था हमने. What is the meaning of that thing? If I am saying resistance is constant, okay, और क्या कह सकते हैं in terms of fluid mechanics? What I can say in terms of fluid mechanics? देखो, हमने मास ट्रांसफर ही पढ़ चुके हैं ना ये. राइट, दिस इज द थिंग ना. तो बताइए हाउ टू प्रोसीड फ्रॉम हियर. What is the meaning of resistance if I am saying resistance is constant? बताओ. कोई लिखना मत अभी, मैं सब कुछ लिखवाऊंगा आपको. Don't worry about that. Don't write. I will explain to you. बताइए, what is the meaning of resistance if I am saying resistance is constant? अरे नीचे नोटबुक में चेक करो, देख के, मुझे मत देखो, मैं तो कांस्टेंट ही हूँ.
रेजिस्टेंस कांस्टेंट है तो यानी Q नॉट भी कांस्टेंट
है, वो मैं मानता हूँ, that is the fair thing. But what is the meaning of resistance is constant? If I am saying resistance is constant, what is the meaning of that thing? जल्दी बताइए, इसके बाद क्वेश्चन सॉल्व करने में 2-3. Hurry up. Okay, that is for your homework, right? अभी मैं पूछूंगा आपसे अगली क्लास में. Now, हमने क्या बोला? Q is equals to driving force divided by resistance, right? Now, for that, what is the meaning of that thing? My flow is there. My flow is there from a hole or from a pipe. When the power of this, the power of H, that is N, is less than 1. Can I say this thing? The flow is there without any external support. The flow is there in the pipe without any external support when the value of N is less than 1, right? But if I am saying the value of n in this case is greater than n 1, if the value of n is greater than 1, what is the meaning of that thing? Means we are providing some external force, that is pump. That is pump. Yeah, I have converted this one in the standard form like this. Okay, and I am saying the value of n is here is less than 1. And when the value of n is less than 1, I can say the flow is there without any external support. This tank is there. Okay, we are not providing any pump now. It's counterbalancing by itself. There is no external support now. By counterbalancing with the help of hydrostatic pressure, it is providing this thing. It is providing a flow now, right? But when the value of n is greater than 1, you will see later on in the fluid mechanics, when the value of n is greater than 1, okay, we are providing some external force, that is pump, right? Now, we want some ideal case. We want some standard case. So for that, I am saying we took some assumptions. 3 to 4 assumptions are there. First assumption is that, first one is your density is constant. It's the first assumption. Second assumption is that, first, density constant. Second assumption is your resistance is constant. Third one, no losses is there. No losses is there in the pipe. Free from any losses. Fourth one, this Q is linearly dependent on H. This Q is linearly dependent upon H. We took some assumption. So when I am saying linearly dependent, no losses is there, resistance is constant, that means this equation is converted into what? Q is equals to H by R. Right? Got the point? So we took some assumptions. मैंने क्या कहा, जो Q है मेरा वो linearly dependent है H पे, कोई losses नहीं है, there are no losses in the pipe, and I am saying resistance is constant, and I am saying density is constant, right? So this equation will changes into, or this equation is changing into this equation, okay? Or I can say more appropriately, I can also say that when the value of n is less than equals to 1, can I say the flow is there without any external support? We can also say, na, flow is there without any external support. This is the real case, and this is the ideal case. Can I say this thing? बोल सकते हैं कि नहीं बोल सकते, बताओ? बोल सकते हैं? ओके, देखते हैं आगे बोल सकते कि नहीं बोल सकते, देखेंगे, राइट? बट अभी के लिए this is the case, right? Now I got this thing. Now I can apply here also in this equation, because we get a relation ना within Q naught and R, right? Okay, apply करते हैं, देखते हैं क्या आता है. We will see. So basically, our resistance is ideal. My resistance is ideal. There are no losses in the pipe, right? And my Q is linearly dependent upon height, that is H, right? So we can say from here that Q naught is equals to H by R, right? Q naught is equals to H by R. Now, this is a basic equation. Here Q naught, Qi is varying with respect to T, and H is also varying. We have to cancel out the initial value because we don't know the initial value of Qi and Q naught. Now for that, can I take at steady state this equation? So by taking the steady state at this equation, what you will get? QISS minus Q naught SS is equals to A DHSS divided by DT. Yes or no? Right? Okay. Similar to this one, can I also take this as Q naught SS is equals to HSS divided by R? Yes or no? Right? Subtract this equation with this equation and this equation. What you will get? QI, right, minus Q naught is equals to A D H by dt. Q naught is equals to H by R. Yes or no? Right? Apply the Laplace here and here. What you will get? Okay, before applying Laplace, what you will say? Replace Q naught with this one, Qi minus H by R A dH by dt. Now apply the Laplace, what you will get? Qi s minus Hs by R is equals to A into S into Hs. Yes or no? Right? Multiply R on both the sides. What you will get? Qi S into R is equals to what? AR into S into HS, right? Plus HS. Take HS common. What you will get? HS into AR into S plus 1 is equals to R QI S. Yes or no? इतना क्लियर है सबको? अब इसके बाद क्या बोलेंगे हम यहाँ पर? After this, I can say HS divided by QIS is equals to R divided by AR into S plus 1. Now, when I see this equation, this equation looks like first order system equation that we have explained, right? What is the first order system equation? GS is equals to KP by tau PS plus 1. Now, if I compare this equation with this one, I can say Kp is equals to R and tau P is equals to AR. Yes or no? So from here, I can also say that HS divided by QIS is equals to what? Kp by tau PS plus 1. So we have modeled our tank system or liquid level system to the first order system with the help of mass balance and Laplace transformation, right? And some basic assumptions. Done with this thing? Everything is clear? Now, first of all, write down this topic, okay? Then draw this diagram first. इतना लिख लीजिए पहले. हाँ सर.
यहाँ हमने स्मॉल क्यू लिया है, इधर पे स्मॉल कैपिटल क्यू लिया है.
डेविएशन का फॉर्म में लिख दिया ना हमने, इसलिए डेविएशन की फॉर्म में लिखा. हाँ, कहीं कहीं आपको ये भी दिखेगा in different books, or you can say in different areas, you will see Q I bar is also there. That means in the form of deviation variable. Okay, वो डिपेंड करता है पर्सन टू पर्सन. मेरे को ये अच्छा लगता है.
और अगर हम इसे लिखना चाहें तो डेंसिटी को इंक्लूड करना जरूरी है, क्योंकि आगे जाके तो ऑप्टिकल है.
मास फ्लो रेट है, इसका मतलब है पर फ्लो रेट का मतलब क्या होता है? मास फ्लो कर रहा है पर सेकंड कितना, क्वांटिफाई किया ना हमने कि हर सेकंड कितना मास जा रहा है. Mass flow rate in, mass flow rate out. This is mass in, not mass in. This is mass flow rate in. This is mass flow rate out. लिख लेना. फिर क्या तो सर ने तो ये लिखवाया था. Online students got the point. First, write down this topic, then draw this diagram. अभी लिखना मत, ये मैं लिखवाऊंगा आपको थ्योरी पूरी, ठीक है ना? कभी लिखने बैठ जाओ, बस डायग्राम बनाने के बाद बोल देना कि सर कंप्लीटेड डायग्राम इन द कमेंट बॉक्स, सो वी विल मूव फॉरवर्ड। जल्दी बनाओ डायग्राम। बन गया? चलो लिखिए। This tank system, this tank system is the physical proof. This tank system is a physical proof of a first order system. This tank system is a physical proof of a first order system. Full stop. At the initial steady state, the inlet and outlet flow rate are same. At the initial steady state, the inlet and outlet flow rate are same, such that the height of the liquid level in the tank is at the steady state. The height at the liquid level in the tank is at the steady state. Full stop. इसके बाद लिखिए, if a step change is introduced in inlet side, it will cause the level to change. It will causes level to change. It will causes level to change, which in turn changes the hydrostatic pressure, which in turn changes the hydrostatic pressure, applied by the liquid level on the wall, hydrostatic pressure applied by the liquid level on the wall, and and ultimately the outlet flow rate and flow rate starts to increase, and ultimately the outlet flow rate starts to increase. Full stop. After the infinite time, here infinite time means a large time. Okay. After the infinite time, the inlet and the outlet flow rate become same. After the infinite time, the inlet and outlet flow rate become same, and height of the liquid level in the tank, is again reaches to steady state. At steady state. फुल स्टॉप. अब पढ़ लीजिए इसको एक बार जो लिखवाया मैंने. डन, क्लियर है इतना? ओके, एक मिनट देख लेना, इससे पहले लिखने से पहले एक मिनट देख लीजिए. सो व्हाट इज हैपनिंग हियर? First, it is at steady state. Okay, some disturbance occurs in the system. It will tend to affect the height. So height is adjusted in such a way that inlet and outlet flow rate will become same after some period of time, a large period of time, right? So from here, I can able to understand that this system is self-regulating system. It regulates itself. Okay, it regulates itself. Nothing external force is applied on this one in order to regulate this system again at a steady state. It is regulated by itself. So this system is a self-regulatory system. Yes or no?
Yes.
It is a self-regulatory system.
What if you increase the flow rate, inlet flow rate, without changing the resistance? The height increases and there is a problem of overflowing. Right?
That's a different case. That's a case of purely capacitive system. We are going to discuss that thing also. We are going to discuss. But that's the second case of the tank series system. Right. Now, see, that's the case when pump is provided. Constant displacement pump is provided. When you provide a constant displacement pump, in that case, it will become overflow. Right? That's a different case. That's a case of purely capacitive system. Right? Now, क्या बोल रहा था मैं भूल गया. बताओ मुझे. कहाँ पे थे हम? Self-regulated system. Right? So it regulates itself without any by using external forces. Right? So this system, the tank system, is also known as self-regulatory systems. Now, after I disturb its steady state, it again attains the steady state and it will not overflow. It will not overflow. What is the meaning of overflow? Means h is tending to infinity. The simple meaning is that h is tending to infinity. Here h is not tending to infinity, na. So can I also say that when a step change is provided in a first order system, I am getting a bounded output? Yes or no?
Yes, sir.
Right? So I can also say that the system is a bounded system. The system is a bounded system. So whenever I am providing a bounded input, I am getting a bounded output. Right? So we can also say that the liquid tank level system or tank system is also known as what? Bounded system, or we can say self-regulatory system. Clear it now? Online students, everything is clear till now? Yes or no? Write down in the comment box, please, so we can move forward. Okay, if you are done with this thing, write down. उसके बाद लिखिए, write down after this one. वो लिखूंगा what is self regulatory system, बताऊंगा आपको. ओके, इसके बाद लिखिए जो हमने लिखा था अभी. उसके बाद लिखिए assumptions. Write down assumptions. Write down assumptions. Write down first assumption. Density is constant. Write down first assumption. Density is constant, and it's an isothermal system. Density is constant, and it's an isothermal system. Full stop. Full stop. Isothermal system. क्या होता है isothermal system? Constant temperature. पर कैसे रखते हैं constant temperature? अगर मैं कह रहा हूं कि आइसोथर्मल सिस्टम है तो कांस्टेंट टेम्परेचर कैसे रखते हैं सिस्टम के? अभी लिख लो, पहले उसके बाद पूछूंगा. लिखिए सेकंड वन, सेकंड assumption. राइट डाउन all the capacity or capacitance to store the liquid lies in the tank only. All the capacity or capacitance to store the liquid lies in the tanks only. Right now, next assumption. All the resistance to the flow, lies in the wall, lies in the well. lies in the valve. उसमें lies in the valve. Right on second one. Okay, it is not the second one. It is fourth one, na? Okay, fourth one. Uh, fourth one. The flow rate. Right on. The flow rate. The flow rate. That is Q naught here. The flow rate is assumed to be linearly related to H. The flow rate is linearly related to H. Linearly related to as, assumed to be linearly related with the H. Okay. अगर मैं ये ना लिखूं तो उसका क्या मतलब है? N हो गया ना? That's the N. Done. Now write down. उसके बाद लिखिए. This is the fourth point ना जो आखिर में मैं लिखवाया था. उसके बाद लिखिए the second and third point. लिखिए second and third point are the second and third point are the lumping. Write down the second and third point are the lumping of parameter. Are the lumping of parameter. बताऊं भाई लिखो तो सही. Are lumping of parameter and by this and by this model is called as and by this model is called as lumped parameter model. This model is also called as lumped parameter model. Now, when lumping is there, it is called a lump parameter model. When lumping is not there, we can call it as distributed parameter model. Right? So, what is lumping? Because you have studied this lumping of parameter, lumped parameter in your heat transfer. पीछे वाले से देखो क्योंकि मैंने सोच के बोल रहा हूँ, मैं कहीं लिख नहीं रखा है. देख लीजिए इनसे. तो क्या बताया था? लंपिंग. हाँ, आपने हीट ट्रांसफर पढ़ा था. दिस थिंग. व्हाट इज लंप पैरामीटर मॉडल्स? क्या होता है लंपिंग? अरे बताओ ना, भूल गए क्या? ऑनलाइन स्टूडेंट्स, एनीवन नोज अबाउट लंपिंग? एनीवन?
If the parameter is constant, let's say in the time, temperature is constant at every point in the time. Then if the parameter is constant in the whole system, then there is some.
Okay, so what is distributed model?
If the parameter, let's say temperature in a flow reactor, it's different at different points. So it's distributed.
Okay, you can say this thing also. Okay. So what is happening here? All the capacity lies on this side. Okay, all the capacity lies on within the tank, but all the resistance lies on the valve side. Okay, we know that resistance is also there. Resistance is also there in the pipe, but we are saying all the resistance lies in the valve side, and all the capacitance lies on the tank side, right? So there is a boundary. You can say there is a boundary in between that distribute. Okay, capacity on one side, all the capacity on one side, and all the resistance on one side. When such scenario occurs, we call it as lumping. Right? We call it as lumping. Okay. Or you can go with this way. Okay, one and all the same thing. But you have to specify that thing. What are the parameters that you have to take constant? Now, this is a lump parameter model, right? उसके बाद लिखिए, after this write down another point. The above system can regulate themselves. The above system can regulate themselves without the need of any controller, without the need of any controller or any human intervention, the system can regulate themselves. क्या लिखा था? Without the need of any controller and human intervention or human intervention are known as self-regulatory system. Are known as self-regulatory systems.
They are self-regulatory, and what is the need of studying this first order system?
Again?
So this is self-regulatory and control system is not required.
Okay.
Then what is the need of studying the
Yes.
See, we are discussing, we are studying these things for what purpose? The first purpose is that after this disturbance, new steady state will achieve. New steady state will achieve. But in the industry, I want to keep my steady state at the old steady state, right? So for that, what will happen? I need some controller that will control the resistance of the valve in such a way that this Q naught will increase. Okay, and when Q naught is increased, what will happen? H will decrease and it will reach to the initial steady state. That's why we are studying these things, in order to maintain the original steady state. Because after the intervention, after the disturbance, okay, I will achieve a steady state, but that's a new steady state. But if I want a new old steady state, what will happen? I want to, or you can say, I need something, a human intervention or external intervention to maintain the initial steady state.
if you rotate the wall, then Q naught, if suppose Q naught earlier was 5,
5. Okay.
and QI is also 5,
Okay.
and then let's say 5 is increased to 10,
Okay.
new steady state,
Okay.
and then you increase R.
No. At that see, I'm not increasing right now. I'm not increasing the R. Okay. I am saying after some time it will reach to the this one.
Yes.
Okay, and this will reach to the new steady state, right? But I don't want to keep this steady state. So yes, at that time I will open the valve in such a way that this will increase, but it will remain constant, and it will reach to the this HS, and then again I close the valve to the 5 flow rate.
But QI will remain at 10, right?
QI will remain at
At 10.
yes.
Then that is not old steady.
Yes, that's why I need some controller, na. Before this one is also some controller is also there that will regulate the flow rate also, inlet flow rate. ऐसा नहीं कि यहीं पे ही कंट्रोलर रहेगा आपके पास, यहाँ भी रहेगा, आगे पढ़ेंगे हम. Okay, that's the controller part, control system part.
If you are regulating the controller, we cannot say that it's a self-regulating system.
Yeah. Yes. No. Because according to my need, according to my aim, the system will change. But here, what is happening? This particular system attain a steady state. Yes, it's a new steady state, but it attains the steady state. Now, when such condition occurs, we will say it's a self-regulatory system. But it regulates itself now without any intervention, external intervention, that is human intervention or some specific intervention.
They want to maintain the steady state because they are the issue. Then
So we have to apply the controller. But the basic definition of self-regulatory system is what? Without any human intervention, if it reaches or if it attains a steady state, we don't know which steady state, but if it attains a steady state, that means self-regulatory system. It regulates itself. क्लियर है? अरे आपसे पूछ रहा हूँ, वहां तो मैं देख रहा हूँ. हाँ, क्लियर है? ओके. आगे हम पढ़ेंगे इन कंट्रोलर, वी विल स्टडी, पर सारा एक साथ नहीं पढ़ सकते. बताता हूँ वो भी क्लास के बाद. ओके, डन. नाउ उसके बाद लिखिए, नाउ राइट डाउन दिस थिंग, स्टार्ट फ्रॉम दिस थिंग, मास फ्लो रेट इन इज इक्वल्स टू मास माइनस मास फ्लो रेट आउट इज इक्वल्स टू एक्यूमुलेशन, एंड राइट डाउन दिस थिंग टिल दिस पॉइंट. कितना लिख लीजिए? Online students, if you are getting any doubt in this one, you can ask me right now. अब बताओ बताओ क्या
ये कौन सा टर्म था बताया ना, कैपिटल क्यू है का नोटेशन बताया था, ये
डेविएशन
डेविएशन।
ओके डन इतना क्लियर है? ओके इसका मतलब आप क्वेश्चंस कर सकते हो आप इससे रिलेटेड ना. ओके नाउ इफ यू आर गेटिंग दिस थिंग, what is the value of this is the what is the value of hs? Let's suppose if a step input is there in the inlet flow rate, right? Step input in inlet flow rate, it is m by s. Itna clear hai? Right? So what is the value of hs? hs is equals to what? M by s into kp by tau ps plus 1, right? This is similar to the previous one, first order system with the step input. So can I directly write this as h of t is equals to mkp 1 minus e power minus t by tau p? Yes or no? Right? Okay. Now इसके अलावा और क्या लिख सकते हैं इसमें हम? h of t minus hsst is equals to mkp 1 minus e power minus t by tau p. So when they are asking about what is the change in the height, change in the liquid level, you need to calculate this one. When they are saying what is the final height that it will take, you need to calculate small st. Got the point? Now here, what is the value of Tp, tau p? Area into resistance. What is the value of Kp? Only resistance. Write down this thing also. Honest, got the point? Everything is clear?